Okay, so imagine this massive, incredibly complex targeting system, and it's running against a ticking clock. We're talking about a world where the difference between, mission success and total disaster is measured in milliseconds and tenths of a degree. That's the reality for the U.S. Army's Fire Direction Center, the FDC. They're the brain of the operation.
They absolutely are. They're the human and the digital brain that takes a call for fire and turns it to steel on a target miles away. And if you're one of those brains, the standard for accuracy and speed, it's just non-negotiable.
And that's what we're digging into today. We've got the Source Material Training Circular 309.8, specifically changed to from June 2025. This is the rule book. It dictates how FDC crews get certified.
Right. And our mission here is to unpack this whole methodology, these things called artillery tables. It's all about understanding how they build these high-precision specialists to work, even when, the tech gets completely wiped out.
The famous crawl, walk, run strategy.
Exactly. It's standardized across every kind of unit, from heavy armored brigades to striker brigades. Everyone who shoots has to follow these exact steps. It's all about resilience and lethal accuracy, no matter what.
So let's get into what's new in this 2025 update, because the changes, they give you some really big clues about where the Army thinks the next fight is going.
The first thing you'll notice is a personnel change. The Senior Fire Control NCO is now officially the Fire Control Master Gunner, or FCMG.
Okay, so that's more than just a name change, right?
Oh, it's significant. It elevates the role, centralizes responsibility for training, for standards across the entire community. It puts a master craftsman in charge.
But the change that really jumped out at me was for the AFA TDS operator. That's the person on the actual fire control computer. They now have to take the leadership written exam. Why? Why force a tech specialist into a leadership test?
That's the key question, isn't it? It's about building resilience into the system itself. The Army is saying that operator isn't just a button pusher. They're the linchpin. And if that system goes down, they need to know why it failed and how to immediately switch to a backup. It's forcing critical thinking at the point of digital execution.
I see. And it also pushes the new master gunner to train everyone on both cannon and rocket tasks, no matter what their unit has.
Create a well-rounded specialist, a 13J who gets the whole picture.
And all of this urgency, it's driven by the why. It's a direct response to a pretty stark Army white paper, right?
Yes, the FA Degraded Operations White Paper.
Yeah.
And it makes some let's say, brutal assumptions about the next conflict.
Brutal is a good word for it.
It assumes the enemy will have serious electronic and cyber warfare capabilities. They're not just capable of it, they will disrupt GPS. They will jam your communications, both line of sight and beyond. They're actively trying to make the FDC blind and deaf.
So the whole training model is built on the idea that you can't stop the jamming, so you have to be able to fight through it.
Precisely. And that starts with the individual soldier. Which brings us to Artillery Table 1. The crawl phase.
ATI, pure individual mastery. And the stakes are, well, they're immediate. You fail one task, you get a NO go, and that's it. Your whole crew stops until you're retrained and retested.
It's the ultimate gatekeeper. And the very first thing they face is the written safety exam. For leaders, that's a 90% pass rate. But, and this is the important part.
Let me guess. The math has to be perfect.
You have to score 100% on the safety computation portion.
Wow.
A single mistake in calculating something like minimum quadrant elevation, which keeps the round from hitting a hillside right in front of you, is an immediate automatic failure.
So there's literally zero margin for error in the process.
Zero. This job demands perfect adherence to safety.
Okay, so once you pass that theoretical test, you're into the hands-on lanes. I'm looking at the diagram here. It looks like a circuit of different stations.
It is. Think of it like a stress test. The clock is ticking, and you're forced to switch between, a 21st century digital system and 20th century analog tools.
Yeah.
1 minute you're setting up a Syntagar's radio, the next you're literally drawing on a paper firing chart.
And this is where we see those individual roles come into play, right? The HCO, the VCO.
Yes, the horizontal control operator, the HCO, they're on the primary chart and a semi-digital system called Centaur. But the vertical control operator, the VCO, their world is almost entirely manual. They're using things called the graphical firing table, or GFT, and the graphical sight table, GST.
Okay, for someone who isn't an artillery nerd, what are the GFT and GST?
Think of them as the analog lookup Bibles. When the main computer is dead, you pull out a pencil, a protractor, and these huge books of pre-calculated data. You use them to manually figure out corrections for air density, for projectile drift, for altitude. It's complex, manual arithmetic, and the VCO has to nail it. perfectly.
And while all this math is happening, you have the RTO, the radio telephone operator, just trying to keep communications up.
Right, and they're meticulously writing everything down by hand. On a DA Form 4504, the record of fire, that piece of paper becomes the official log, the only record you have when the digital network is gone.
So after all that, you get a D go or NO go, and the commander gets a debrief on where the team's weaknesses are.
Exactly. Only then, once every individual is certified, can the unit move to the walk phase, tables 2 and 3.
This is where it becomes about the team, not just the individual.
Right. Artillery Table 2 is all about tactical survival. If the enemy is hunting your electronic signature, you have to be fast and invisible. So they practice advanced party procedures. Basically, the art of picking a hide site that offers concealment from electronic detection, but still lets you communicate.
And then table 3 is about getting set up in that location fast.
Incredibly fast. They have to hit a status called in position ready to fire, or IPRTF, within a strict time limit. That means comms are up, voice and digital, and you have the data for what we call the 5 requirements for accurate fire.
And they do a verification mission here, a bump mission. What is that?
It's a critical safety check. It's a dry run. No round is fired. The FDC computes a fire mission and sends it to the gun line. They're checking to make sure the data they sent is the exact same data the gun crew is seeing. If the numbers don't match, you stop everything and fix it before you ever load a live round.
Makes sense. And there's a new task here in table 3 about air movement.
It shows the FDC isn't a static headquarters. They have to be able to pack up, get on a helicopter, support an air assault, and be back up and running just as fast on the other side.
Okay, so the team is set up, they're ready. Now we get to the core of it all. Artillery table 4. Computing firing data. This is the run phase, right?
This is where the real pressure comes on. It's the engine room. They have to prove they can handle complexity and volume. They get hit with different types of missions grid coordinates, polar plots shifting from a known point, and they have to move between them seamlessly.
But the real stressor here is the SIMO requirement, simultaneous missions.
Absolutely. Fire missions don't arise in a neat little line in combat. You get 2 at once for different targets with different ammo, and you have to process both at the same time. Without getting anything crossed, it tests your internal process, not just your computer skills.
And the types of munitions they're training on cover everything.
Everything, from standard 155mm rounds to precision munitions like the PGK and the GPS-guided Excalibur. They also have to handle things like final protective fires and what happens when you have a fire support coordination measure violation, which is a big deal.
That's a huge computational leap from a dumb round to programming a GPS-guided one.
It is. And on the rocket side, MLRS and HIMARS, they're working with the big stuff, the ATAC EMS tactical missile system, and they're orchestrating complex schedules of fire where multiple rockets have to hit a target at the exact same second.
A coordinated symphony of firepower.
That's a good way to put it. And all that training leads to the final test, the run phase, tables V and V, where they prove they can do it all under intentional chaos.
Table V is the section certification. It's a dry fire evaluation, but it's the big one.
It's the capstone. And this is where that concept of the spectrum of degraded FDC operations comes in. This is the heart of the entire doctrine.
Okay, walk us through that spectrum. This feels like the key takeaway.
It starts at the top. Full operational capability, or FOC, that's your primary method, using the AHAV TIES computer, everything working perfectly. Then you step down.
To a what?
To degraded, alternate. Here, your AHAV TIES is checked by a backup, like the Centaur system or just an old-school paper chart. Commands might be digital, or they might be voice. Even the advanced rocket units have to train this, using voice if their digital link is cut.
So no matter how fancy the weapon, you always have to have a voice backup.
Always. Next down is manual contingency. This is pure old-school analog, chart-to-chart checking. It's pencil, protractor, and the GFT and GST tables. All commands are over the radio by voice. This is for when the system is completely fried.
And the last level.
Emergency. This uses specific bare-bones procedures from the manual for when you need rounds out the door right now. Again, all voice commands.
And for a Canon unit to get certified, they have to prove they can do all of it.
Not just prove it. They must execute at least one mission in FOC, one in degraded, and one in manual mode. If you can only do the digital part, you are not considered ready for combat, period.
That's a harsh standard. And it carries right into the final test, Table 6, which is live fire.
This is the ultimate test. The commander is evaluating if the section can do its wartime job safely, timely, and accurately with real explosions at the other end.
And they have to do it degraded, even with live ammo.
Yes. For canny units, at least one of their live-fire missions has to be processed using either degraded or manual methods.
Yeah.
They might compute a whole high-angle mission completely by hand on a chart and still have to put that live round safely and accurately on target. It proves the whole system works, no matter what the enemy throws at you.
So when you strip it all down, what we've really looked at is this incredibly systematic process. It's not just about being good with the software. It's designed from the ground up for resilience when an enemy is actively trying to break that software.
That's it exactly. It moves from individual safety and analog skills in Table 1 to rapid tactical setup in Table 3. And it culminates in proving you can deliver accurate fires using manual backups in Tables V and 6. Mastery in this world means you can do the job instinctively, precisely, no matter how bad the conditions get.
Which really brings up a final, powerful question for you to think about. When you look at the sheer complexity here demanding mastery of 21st century digital systems right alongside 20th century analog tools, pencils and charts, it makes you wonder, is the future of warfare really defined by the most advanced technology you have? Or is it defined by the foundational, low-tech knowledge you can execute perfectly when all that expensive technology is taken away?